All right, we're starting topic 7, rational numbers. This is block 1, and your workbook should be open to page 179. Remember, you might need to pause the video for people to finish writing the notes, or rewind if someone is being noisy. You'll need to remain quiet. All right, so rational numbers. Let's talk about those. We're going to be going over some questions that go along in your workbook, but just hold off. I'm going to come back to it and we'll have time to write down exactly what I want you to write down. So don't worry about writing it just yet. Just watch along with the video. So we're going to look at some vocabulary words, and the first numbers we're going to learn is natural numbers. These are natural numbers, that's our vocabulary word, is the numbers that we started learning counting with. Okay, when we were little kids, we started with 1 and learned 2, 3, 4, 5. We didn't start with 0, we didn't learn negatives, we didn't start learning fractions. This is what we started learning with. That's our natural numbers. So that's kind of how I remember it. Naturally, this is what we started learning. That's kind of how I remember it. So then we learned those numbers. Then we added this number 0, and we started learning about what 0 meant. These numbers plus 0, is the definition for whole numbers. So all of our natural numbers included with 0 is the definition for whole numbers. Then as we got older, we understood these numbers, and so we were able to add some more numbers. And then came the other side of 0, are negative numbers, and we call these integers. We started looking at these. We probably been looking at negative numbers for a while, but we looked at these earlier in the year. These are integers. You have your positive integers and your negative integers, and 0 does not have a sign because it is neutral. So recapping what I just said, I'm ahead of the game. We have our positive integers, 0, negative integers, and all of these are integers. The blue dots, if I just looked at the blue, those are natural. That's what I naturally started learning. Red and blue is our whole numbers. And then all of these dots is integers. Okay, let's go to our workbook and let's answer some of these questions. Number 1 says, what are natural numbers? Natural numbers are our counting numbers, or the same as positive integers. So counting numbers, same as positive integers. Says list 5 different natural numbers. I would do 1, 2, 3, 4, 5, and I would do a ... because it continues on in that manner forever. All positive whole numbers are natural numbers. Then number 3, what are whole numbers? Whole numbers are your natural numbers and the number 0. So it says list 5 different. I would start at 0, 1, 2, 3, 4, ... Keeps going on. Those are whole numbers. Then number 5 talks about what are integers. Integers are your whole numbers with their opposites. And opposites is the opposite of a positive is a negative form. So if I list different integers, I could list -2, I could do a dot, dot, dot in this direction. -1, 0, 1, 2, dot, dot, dot. Those are integers. All right, I'm going to go back to our site here. This is just kind of recapping what we just learned. Integers greater than 0 are positive. Integers less than 0 are negative integers. 0 is an integer, but it's not positive or negative. It's just neutral. Then we're going to learn the definition of rational numbers. Rational numbers, the formal definition is any number that can be written as a quotient of two integers, and quotient means division, where the denominator is not 0, is a rational number. So all of these are examples of rational numbers on the number line. So rational numbers is anything in between the whole numbers on the number line, but it also can be a 0, a 1, a -1. Rational numbers encompasses everything. So, going to our questions in our book. What are positive integers? Positive integers are integers greater than 0. What are negative integers? It's going to be integers that are less than 0. It says describe the number 0. Well, we said 0 is an integer, but it's not positive or negative, it's just neutral. Then, what is a rational number? I want you to write the formal definition, but I also want you to write my not so formal definition. This is how I kind of define rational numbers. It's not 100% factual because you'll learn more about rational numbers as you get older in your math classes, but it's basically a fraction, decimal, percent, or it can be an integer. Well, helps to spell right. Or it can be a whole number. It can be any form of these. But basically it's a fraction whose denominator is not 0, which a whole number can be a fraction because the whole number 4, I could write that any whole number over 1 and make it a fraction. So whole numbers really are fractions as well. And the denominator is not 1. Not 0, so it makes it a rational number. Percents can be written as fractions. Decimals can be written as fractions. That's why they kind of sum this definition up and say the quotient of two integers, because all of these can be written as a fraction. All right, we're going to take a look at slides here. So if we're looking at whole numbers, they picked these random whole numbers, 0, 3, 4, and 5. and they picked 1, 2, 3, 4, 5, and 6. It looks like they added 2. All of those are examples of whole numbers. Okay, well, I can add to that integers is -1, -3, -4, but it's also all whole numbers. That's why these change colors. Integers can be any negative form. It also can be whole numbers. So anything inside this circle, this orange circle, is considered an integer. So whole numbers are integers. Are all integers whole numbers? No, because negative numbers don't fall into this category. Okay. Then we're going to expand that circle. Rational numbers. These are some different rational numbers. Rational numbers can be any of these examples. Could also be any of the integer examples or any of the whole number examples, because it's inside its big circle. So all of these are examples of rational numbers. So for number 11, we want to try and sketch a diagram of that to represent that. So here's a diagram, kind of like what we just had. So 0 could be classified as a whole number, an integer, and a rational number. It falls under all three definitions. But -4 can only be an integer or a rational number. It's not in the whole number circle. Or 1/2 can only be a rational number because it can't be an integer or a whole number. So its only definition would be rational number. All right. So that's kind of what we're going to be looking at. We're going to be looking at fractions, decimals, and percents and doing some math work with it, which is oh so much fun. So that leads us to not this problem. That leads us to problem 12 and 13 are your homework problems. However, I know it's been a long time since you have worked problems with fractions, so I'm going to actually do problem 12 with you so you have a good example and refreshing your mind on how fractions work. So on 12A, I have this problem where I have some number minus 2 3/4 is going to equal 6 1/6, and I have to find this missing number. Well, first thing when I see fractions like this, I want to change everything to improper. That's what I want to do first. I'm going to rewrite this problem and change these fractions to improper. Okay, so I do 4 times 2 plus 3. So 4 times 2 is 8. 8 plus 3 is 11. So that's going to be 11 over 4. Then I'm going to change this next fraction to improper. So 6 times 6 is 36. Plus 1 is 37 over 6. Okay, I changed them to improper. Now I notice that the denominators are not the same, and I'm adding and subtracting something, so I need common denominators. So I need to know a common denominator between 4 and 6. So I like to take my smallest one and count by multiples. Multiples of 4 is 4, 8, 12. I know 6 can make a 12, so I think my common denominator is going to be 12 here. So I'm going to rewrite my problem again. How does a 4 turn to a 12? 4 times what gives me 12? 3. So 11 times 3 gives me my numerator. 6 times what gives me 12? That's 2. So 37 times 2 gives me 74. Now I have common denominators and I can solve this. So I know I need some number, subtract 33 twelfths from it, and I'm going to get 74 twelfths. Well, if I was looking at a simpler problem where it was x minus 2 equals 5, I need some number, take away 2, and it's going to get me 5. Well, I know if I added these two together and get 7, I know 7 minus 2 gives me 5, so my magic number was 7. So same concept, except now I have fractions. So I know I need to add these two together to get this number, and I should, when I take it away, work with this problem. So I'm going to add 74 and 33 over here to the side, and I get 107. So when I add those, I get 107 over the same denominator of 12. So if I take 107 minus 33, I should get 74, and I do. Well, I need to change this to simplify it. So I need to see how many times 12 goes into 107. So I'm going to come over here and test it out. I'm going to try a bunch of multiplications, or I could sit here and divide, but I don't like dividing if I don't have to, so I'm going to test 7. 7 times 2 is 14. 7 times 1, 7 plus 1 is 8. I need 107. So if I add another 12, that's going to be 12 times 8. That gives me a 96. Can I go another 12 and not go over? That gives me 108 that's times an 8, that's times a 9. So I'm over here, I can't do that, so my magic number is an 8. So 12 goes into 107 8 times. And 8 times 12 gives me 96. So how much was left over? 107 minus 96 equals 11. So 11 was left over, and 12 was my denominator. That can't simplify anymore. So 8 and 11 twelfths would be my answer for A. Over here, this is just my scratch work for this problem. Alright, let's take a look at B. Again, I see mixed fractions. It looks crazy to me. I like to look at them as improper. So I'm going to change them all first to improper. 5 times 2 is 10, plus 4 is 14, over 5 times y equals 2 times 10 is 20, plus 1 gives me 21 over 10. All right. Then I notice I don't have common denominators. All right, and I need this number times something, and it's going to give me this. So I like to think of easy problems of how I would do this. So let's say 2 times something is going to give me 6. Well, I know 2 times a 3. How do I end up getting that? What you're really doing is you're saying this number divided by 2 gives me 3. So that means 2 times 3 is going to give me 6. So I know I need to divide this number divided by this number. Okay, so this problem had nothing to do with it. I just used it to help my brain think. So I know this number needs to divide by this number, so I'm going to write that. And do I need to worry about common denominators with fractions when I'm multiplying or dividing? No, I don't need common denominators, so I'm not going to worry about it. So I have 21/10. And we said we had to divide that by 14/5. Well, we never divide fractions. We always multiply by the reciprocal, or as y'all like to say, keep, change, flip, I think. Now I can multiply straight across. So 21 times 5. Come over here, do my scratch work. 5, 10, that gives me 105. 10 times 14, that gives me 140. So now I just need to simplify this. I could divide both of those by 5. 105 divided by 5 goes 2. Bring down the 5. It goes 1, and then nothing's left, so that gives me 21 here. I can divide 140 by 5. 5 goes into 14 2 times. 4's left over, bring down the 0. 5 into 40 goes, having a brain fart, 8 times, so 28. And that can simplify. I can divide both of those by a 7 and get 3/4, and then that would be simplified. So this times 3/4 is going to give me that. Looks crazy because it's fractions, but it's same as that simple problem I just pulled up here. All right, let's try C. Okay, I'm gonna change it to a simple problem to see what I need to do. So I need some letter divided by, let's divide it by 2. Dividing by 2 is easy. Let's change this to an X since it looks like a 2 already. So I need some number divided by 2, and let's say it equals 10. Well, what divided by 2 is going to give me 10? I know 20 divided by 2 gives me 10. So how did I find 20? Really, I multiplied 10 times 2. So I need to multiply these two things together to get this guy. So I need to multiply these things together to get this guy. So I'm going to clear my scratch brain work there. And we just said we needed to multiply these two guys together to figure out what that missing guy is. Okay, so multiply, I multiply straight across. 5 times 12 will give me, come over here, do my scratch work. 5 times 12 gives me 10, 60, 60, 25 times 6, 6 times 5 is 30, 12, 13, 14, 15, gives me 150. Okay, there's a zero trick rule I can use. If I have a 0 on top and a 0 on bottom, they can cancel out and simplify the problem. So really I have 6 over 15 that I simplify. And I know both of those can divide by 3. So that would simplify to 2/5. And that is as simplified as it goes. So my missing Z answer is 2/5. All right, D. So I have a number minus a number, and I need to see what that equals. Well, if I have 12 minus 2, and I want to see what that equals, I just subtract it and I get 10. So there's nothing crazy I need to do here, I just subtract it. First, I need everything in a fraction and common denominator since I'm either adding or subtracting. So I need 14 written as a fraction. Well, it's a whole number. I can write any whole number as a fraction. You can put it over 1. So I'm going to rewrite this over 1. And I want to rewrite this as an improper fraction. So 5 times 2 is 10. 10 plus 3 is 13 over 5. All right, and I need to figure out what that equals, but I see that I do not have common denominators. I have a 1 and a 5. Well, what is in common between a 1 and a 5? 5. That would be the easiest. I don't have to change this guy. I just have to change him to have a denominator of 5. So 1 times what gives me 5? 5. So 14 times 5. I need to know what that is. That gives me 20. 5 plus 2 is 70. So that changes to 70 over 5 minus 13 over 5. Now I have common denominators, so I can subtract the numerators. So, oh gosh. So 70 minus 13. Borrow here. That gives me a 7. That gives me a 5. So 57 over 5. And that needs to be simplified. I need to see how many times 5 can go into that. It can go 11 times and gives me 55. Okay, that means there would be 2 left over. And that is as simplified as it goes. So 11 and 2/5 would be my answer to D. All right, I'm going to have you work problem 13 on your own. However, I'm going to go ahead and give you the final answers so you know if you worked them correctly. So I'm checking the work. So A, you should end up getting a negative 21 as your final answer. B, you should get a 29 as your answer. And C, you should get a negative 10 as your answer. So I'll be looking for the work of these problems. You might have time, if you finish this, to work on some online work. More practice 1 through 4 should be up and running now. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, home dogs.